look at the data set. We are going to build a decision tree to classify yes or no. Okay, whether you can play golf or not, you play golf. Okay, whether you are going to play the golf or not. Okay, now for that you have taken features like outlook, temperature, humidity, and wind. Okay, outlook, temperature, humidity, and wind. 4 features are taken. Okay, so in every 4 features, you see, for example, let's take wind. Okay, let's take wind. 1, 2, 3. I hope all of you are listening, please. We are just moving into, I'll explain with a numerical example how decision trees are calculated. Okay. So using this data set, I'll be telling you how decision trees are done. Okay. Please have a look at it. Now, if you take wind, if you take the overall data set, how many yes are there? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, 9 out of 14 entries are yes. How many no? Then 1, 2, 3, 4, 5. 5 out of 14 entries are no. So how do you calculate the overall entropy? This is how the overall entropy is calculated. There are 9 yes and 5 no's. So 14, totally 14 total entries. So how do you calculate the entropy? 9 by 14. Okay, the formula itself says 9 by 14 log 2 of 1 by p of x. Okay, it should be 1 by p of x. Here it is 9 by 14. Please calculate 1 by p of x minus 5 by 14 log 2 of 1 by p of x. Okay, so the total entropy is 0.94. Okay, how do you calculate log 2? Ln of that number divided by ln of 2. Log 2 means ln of that number divided by ln of 2. Please have this also in mind. So the overall entropy is done. We have calculated the overall entropy. Now, by doing every feature, let's take wind. Okay, how many sections are there in wind? Wind has 2 sections. One is strong, the other one is weak. Okay, let's take strong. How many strong are there? 1, 2, 3, 4, 5, 6 strong are there. Among that strong, how many yes? 1, 2, then 3. 3 yes are there. Okay, so this is how we are going to calculate the entropy. I will show you that video. Just give me some time to share the video. I want everybody to listen to that video. It's a numerical example that shows how the entropy is calculated. Please have a look at it very clearly. The video will also be uploaded in the GCR. You can later on go and check that video also. Just wait. From the data set, it is understood that the total number of yes is 9 and no is 5, and now the total is 14. So we will calculate the entropy. Entropy h of s is equal to summation p of x log 2 1 by p of x. So if we substitute the value here, it is 9 by 14 log 2 14 by 9 plus 5 by 14 log 2 14 by 5. And when we can do the calculations, the value is equals to 0.6428 into 0.6374 plus 0.3571 into 1.4855. So after the calculations, the h of s is 0.9401. So we have many features in the data set. So let's take the first feature, that is feature 1, it's wind. So if we refer the data set, we could understand that wind has 2 parameters. One is weak. There are 8 entries for weak, and the other one is strong, and there are 6 entries for strong. And under weak, there is yes and no, and we could see that there are 6 yes and 2 no's. Similarly, for the strong, 3 yes and 3 no. and it is, let's calculate the entropy for week. So when we calculate the entropy for week, it is S6 by total number 8. 6 divided by 8 log 2 of 8 by 6 plus, again here we will do 2 by 8. 2 divided by 8 log 2 of 8 by 2. So after calculations, it is 0.75 into 0.4150 plus 0.25 into 2.001, and this is 0.8115. This is entropy weak. And then when we calculate entropy strong, it is understood that S is equal to no. The classes are equal. So we have discussed that if the classes are equal, the entropy value is equal to 1. So after we calculate the entropy, we are supposed to calculate the information gain. So information gain for wind is equal to, it's given by the formula of H of S minus summation P of X into H of X. So we'll do here as 0.9401 minus, so P of X is 8 divided by 14. It is 8 strong, 8 weak into entropy for weak plus strong, 6 strong out of total 14 into the entropy 1. So after calculation, it is 0.9401 minus 0.4637 plus 0.4285. So the information gain for wind is equal to 0.04788. So let's take the second feature, that is outlook. So in outlook we have 3 parameters, that is overcast, we have 4, and rain we have 5, and sunny we have 5. So under overcast, yes is 4 and no is 0. Similarly, yes is 3 and no is 2. Here yes is 2 and no is 3. You can examine this very well from the data set. So the entropy of overcast is equal to 0 because all belongs to a single category S. So the entropy of overcast is equal to 0, and let's calculate entropy of rain. So entropy of rain is nothing but 3s by 5 log 5 by 3 plus 2 by 5 log 2 of, all logs of to the base of 2, and log 2 of 5 by 2. So we all know that log 2 to the power of n is nothing but ln n divided by ln 2. So you can do this calculation to calculate log 2 to the power of n. So now from this it is 0.6 into 0.7370 plus 0.4 into 1.322, and it is 0.971. So entropy of rain is calculated as 0.971. And now we will calculate entropy of sunny. So entropy of sunny is nothing but 2s out of 5 log 5 by 2 plus 3 by 5 log 5 by 3. So again this is 0.971. So the next step is we have to calculate information gain for Outlook. Information gain for Outlook is nothing but 0.941 minus 4 overcast. 4 by 14 into the entropy of overcast is 0 plus 5 by 14, that is the raining. The entropy is 0.971 plus, and here also we calculate that it is the sunny is again 5 by 14 into 0.971. So after calculation it is understood that it is 0.2467. This is the information gain of Outlook. So the next feature is temperature. So temperature also we have mild, which is 6, out of S is 4 and no is 2, and also we have cool, which is 4, out of which the S is 3 and no is 1, and hot, which is 4 and S is 2 and no is 2. So here it is understood that the entropy is equal to 1. So now we calculate the entropy for mild. So entropy for mild is 4S divided by 6, 4S divided by 6 log 2 of 6 by 4 plus no divided by 6 log 2 of 6 by 2. And now this is equal to, after calculation, this is equal to 0.9182. Similarly, entropy of cool is 3 by 4 log 2 of 4 by 3 plus 1 by 4 log 2 of 4. Again, this value is equal to 0.8112. Now we will calculate the information gain for temperature. So information gain for temperature is equal to 0.9401 minus 6 by 14, that is mild, into its entropy 0.9182 plus 4 by 14 into 0.81127 plus 4 by 14 where the entropy is 1. So totally we get 0.02919. So this is about the information gain for temperature. Information gain for temperature is calculated this way. Then we will do the calculation for feature 4, which is humidity. So humidity has two. One is high, that is 7, and then normal, again it is 7. So we have high S3 and no of 4. Similarly here S of 6 and no of 1. So we'll calculate entropy high. Entropy high is equal to 3S divided by 7 total log 2 of 7 by 3 plus 4 no divided by 7 total log 2 of 7 by 4. So this calculations is nothing but equals to 0.9849. And similarly, entropy normal is 6 by 7 log 2 of 7 by 6 plus 1 by 7 log 2 of 7. So this value is equal to 0.5915. So we will calculate information gain for humidity is equal to is equal to 0.9401 minus the total, that is 7 by 14 into 0.9849 plus, so again this 7 by 14 into 0.5915. So after calculation, the information gain value is 0.1519. So now we have calculated the information gain of all the parameters, all the features. So information gain of the wind is 0.047, and information gain of temperature is equal to 0.029, and information gain of outlook is equal to 0.246, and information gain of humidity is 0.1519. So now, as this is the largest number among all, this outlook is selected to be the root. So the decision tree start with outlook as a root. So let's have outlook as a root. So under outlook, what are the various categories available? You have overcast, then you have rain, then you have sun. So now if we see overcast, if we see the data set in the overcast, all the overcast will have yes. You can check the data set, all the overcast will have yes. Yes. Now for rain and sunny, we should follow the same procedure that we did now to do temperature, humidity and wind. So under sunny, if we see the data set, yes is 2 and no is 3. So we'll calculate H of S, the entropy, which is 2 by 5. The total is 5. So log 2 to the power 5 by 2 plus 3 by 5 log 2 of 5 by 3. So this value is equal to 0.971. The H of S for sunny is 0.971. And now let's take the feature 1, that's the temperature. We'll take the temperature, and temperature, if we take the temperature, so under sunny, so temperature we should take under sunny. If we take, there are 3, hot, which is 2, and mild, which is 2, and cool, which is 1. So for hot, S is 0 and no is 2, and mild, S is 1 and no is also 1, and here yes is 1 and no is 0. So now here we see that it belongs to only one class, no. So the entropy of hot is equal to 0. Similarly here, two classes are equally divided, so entropy of mild is going to be 1. And here also it is only S is available, so entropy of cool is equal to 0. So now we'll calculate the information gain. So information gain of temp underscore sunny is 0.971. So minus. See, all the other are done with. The hot is 0. So the cool is also 0. We need not include that. Only thing we will be including is a mild. 2 by 5. That is 2 mild into 1. So the value is around 0.571. Similarly, for humidity, we will take high. There are 3 high, and S is 0 and no is 3. And similarly, normal. Also, we have 2, where S is 2 and no is normal. So now you can guess what will be the entropy of high. Entropy of high is also 0, and entropy of normal is also 0, because everything is confined within a single class. So it is 0. Now what will be the information gain is information gain of humidity underscore sunny is 0.971. Alright, and then there is one more feature, that is wind. We have to calculate for the wind. So wind, we take wind, we have weak, 3, where S is 1 and no is 2, and we have strong, which is again 2, where we have S as 1 and no as 1. So entropy of weak is equal to, we can write the equation, that is 1 by 3 log 2 of 3 plus 2 by 3 log 2 of 3 by 2. And now here this is, it's all equally divided, so entropy of strong is equal to 1. So this value is equal to 0.9182, and information gain is 0.970971 minus of 3 by 5 into 0.9182 plus 2 by 5. So this information gain of wind is 0.019. So now the information gain of temperature is equal to 0.57, and information gain of humidity is equal to 0.96, and information gain of wind is equal to 0.019. So already we have constructed the tree, that is the outlook is divided into 3 categories. One is the overcast, which straight away leads us to yes, and now the rain, and then comes the sunny. And now we have now calculated for sunny. So among this 3 information gain for temperature, humidity and wind, it is understood that the humidity takes the highest value. So from sunny, we just built on humidity. So when you examine the data set, humidity has 2 values. One is high, the other one is normal. So now from the data set, the high, under high, if you see, there is no S and all are no, only no is present. And similarly under normal, if you see that only yes is there. You can check out the calculations that we did previously. So in that, we have constructed the decision tree to this level, where outlook is taken as the root. From outlook, we have taken 3 parameters: overcast, rain and sunny. So now if it is overcast, yes, the match will take place. But now if it is sunny, you have to check out the humidity also. Now if you check out the humidity and the humidity is high, that there is no way that the match will take place. And if it is normal, the humidity is normal, yes, the match will take place. Now considering the rain, here you have two parameters. One is the temperature, the other one is the wind. So again we have to do from the first, calculate the entropy of rain. So for entropy of rain is calculated as E of rain is calculated as 0.971. And now here we have to calculate the temperature. For temperature, you should calculate for S as mild and cool. There are two categories here, mild and cool. So if you calculate the entropy of mild is equal to 0.9182 and entropy of cool is 1. And information gain also you can substitute in the formula that we used earlier, 0.19. And similarly, the other one is the wind. So under wind, there is weak and strong. So it is understood that the entropy is 1 each. There are 3 weak and 2 strong, and the entropy is equal to 1 for these two. And now the information gain is going to be 0.029. So comparing the information gain of temperature and information gain of wind, wind wins the race. And here now we are going to categorize from rain, we are going to take wind. So if it's really rain, you have to consider the wind. So under wind, there are two. Whether the wind is weak, then if the wind is weak, yes, the match will take place. But if the wind is strong, no, the match will not take place. So this is how we build the decision tree. So how do we build the decision tree? First, we calculate the overall entropy H of S. Then we calculated the entropy for outlook, overcast, rain, sunny. From that, we calculated the information gain. Based on the information gain, we decide who will be the root node, who will be the leaf node, and from the leaf node, who will be the child node. So in that case, we constructed the decision tree.